my first time at ngAtlanta. I've been at Ultimate for 6 years now, and I've been doing a lot of speaking on different topics. And I can tell you this, like, this is something very unique and special, this conference. So y'all need to hold on to this community because I've never experienced anything like this, and I've been all over the world last year, Portugal, Budapest, all over. And this is very unique with the diversity here, so great job. So I work at Ultimate Software. I work with Zach, actually, in the architecture group, leading quality, whatever that really means. And we have a small research team that is responsible for doing research on the use of artificial intelligence and machine learning to help bridge the gap between what is manual and automated testing. Because what we call automated testing today is not really very automated, right? It is a manual creation of test scripts, and the only part that is automated is execution, right? And so there's a lot of advances in machine learning that can help us bridge that gap, right? So I was actually very surprised that Zach trusted me to do this talk in front of all his peeps. But you know, I know the kind of crowd that we usually have when I talk is usually a bunch of testers, which are very skeptical people. So the first item in my agenda is actually a disclaimer. But I know we don't have all testers, so this is a very optimistic crowd. But nonetheless, I need to set the stage to make sure that you guys know that I'm not, you know, talking crap. So then we're going to get into what is AI-driven testing, what we really mean about that, and some of the challenges that it presents, especially when it comes to UI design and so on and so forth, and how we've leveraged Angular-based frameworks to really help us overcome some of those challenges, right? And so that's kind of the first piece of it, and we'll kind of see some demos as we go along of the product that we build and some of the internal tools that leverage Angular. And more importantly, which is also an aspect of this title, is what I think the UI and UX community and the software testing communities can do together by joining up to actually make things like AI-driven testing a reality, right? And so we'll talk a little bit about that before we wrap up. All right, so disclaimer. First thing, that this is not a trick. And I am definitely by no means a magician. And this entire presentation, I guarantee you, is a work of truth. The products and the tools and the frameworks described are all real things. Some of them you've used, some you may not have. And most importantly, no testers or developers were harmed during the development of these products. But I'll be honest with you, part of this will feel like magic, right? And that's because artificial intelligence and machine learning, like those things always tend to feel like magic, like the future, like how does this even work? And truthfully, we don't actually understand how a lot of it works behind the scenes, but we're using it and we're actually trusting it more and more, right? It's kind of scary, right? That we just are trusting it. And so I feel it's like my civic duty as a tester and quality-minded person to kind of start investigating the trustworthiness of those systems, but also interested in what it can do for me, right? And so the truth is that the bots are here. And we're teaching them to do lots of things. Now, we've taught them how to test software. This is 2 products that are actually using autonomous and intelligent agents to navigate through the application, explore, discover what is there, generate test cases using testing techniques, and mimic human testers, right? On the left, one is running on the web using multiple agents that are coordinated, and on the right, one is doing exploratory testing and making mistakes and learning from those mistakes. And it's interesting because, you know, when I started working in this space and we started investigating this stuff, I met up with Jason Arbin, who's the CEO of Test.ai, and we were like the 2 only people working on this stuff. And so that's why we started ASTA, which is an association around this topic. But again, it is actually not magic. So let's first take like a 10,000-foot view of how this stuff really works. And so we have these bots doing AI for testing, or AIST. And the first thing they need to be able to do is actually explore and perceive that user interface, right? Its structure and its behavior, and any kind of differences that it notices. And so it starts with the UI. And there's a lot of different techniques for teaching it how to perceive. Image recognition is one, right? You can train it using images, and there's a lot of machine learning advances around image recognition. And then there's things like the DOM and the CSS object model and the computed render trees that give us a wealth of information about what is there. And you can train it using that information. And so that's the first step. And so understand that machine learning and artificial intelligence are an integral part of every step of what these bots do, right? So as they go through and they explore and they discover, they're building models just like humans do. Building models that help us with uncertainty, help us to make decisions, right? Is this a good decision? Do I have confidence in taking this action? Is there a high probability that a human would do it, so maybe I should take the same action? And so there's lots of different models that you can use to do that. And one of the most popular models you'll see is just kind of like a finite state machine. Very useful for testing, but not exactly very scalable, right? All right, so you have your models, and the next thing you want to do is actually interact with the application. You need to be able to generate inputs. You know, I want to click on things, tap on things, swipe things. I need data to be able to get through and discover the different flows, right? So I need to exercise those. And then I need to observe the outcomes and make sure that things are what they seem, right? This is testing. This is not just walking randomly and doing nothing, right? And so initially, to be honest with you, the machine isn't very smart. The machine says at random, oh, let me just pinch to zoom on this menu box. Just not very intuitive. And maybe later on it decides, let me tap on the menu button. And the cool thing there is that it learns, right? So it doesn't have to be great at first because you randomly initialize the neural network. But then later on, it gets direct feedback on the quality of its actions. Like, that was good. Do more of that. That was bad. And so then it can improve as it gets better. And so that aspect of it is what's very desirable, where we punish the machine or reward the machine for its actions, and it knows how to improve. So what does all this initially have to do with Angular? Well, we obviously had to make some decisions when we first started working on this project. You know, luckily, like, I work for a company that loves to invest in the future. And so they said, yeah, you know what, we're going to do this AI stuff. And you're going to be able to get a team, and you're going to start working on it, and so on and so forth. And so we had to be in rapid prototyping mode. Like, we got to experiment with things. Like, this is research. If someone had done it, it would be a solved problem. It wouldn't be research. So by default, we got to fail quickly, and keep going, and so on and so forth. That model that I mentioned gets very big, right? So we had visualization challenges there. The presentation of all this data that is generated by the system. And then, of course, data is like your first-class citizen, so you talk about training, and there's a lot of different issues around training. So we're going to step through each of these challenges and kind of see, like, where we use Angular-based frameworks to help us. And the first decision was easy, right? Rapid prototyping, like, we had to make sure that we could facilitate having many user research studies. And we're talking about user research studies with engineers, developers, testers. And these are critical people. So, you know, first of all, whatever you bring in, it has to come correct. And then after you bring it, they're going to say, well, I don't like that. And so you're going to have these rapidly changing requirements all the time. And that's okay. I mean, we all deal with rapidly changing requirements. Just in this context, there's a lot of variables because of the R&D aspects. And so we went with our core frameworks, Angular and Ionic, for reasons that are very familiar to you. Like, I don't need to preach to the choir about the modular design and the reuse, right? Especially in a rapid prototyping mindset, like, you need to be able to reuse as much as you can. The other thing that's also key there, especially when designing testing tools and frameworks, is opinionated approaches, right? Like, guiding people towards what you think is the right thing. Like, we use that in our own framework designs because we want people to not just do crazy things when they're creating tests and creating automation, right? And so that was also very appealing. And of course, these user studies were going to be on multiple devices, different form factors, tablets, phones, et cetera. And so the responsive design was a key thing there. And at the end of the day, if you're building a system to test other systems, you better make sure that it itself has been tested well. And so a lot of the benefits around testability, played a part in our decision. But that's easy challenge, right? Just pick some frameworks and move forward. For the visualization of the model, we really had to make sure that we stepped back and could try to solve that challenge. Remember, these bots are going to be exploring multiple bots at a time, creating all these states and transitions between states and so on and so forth, identifying all the elements and widgets and the behaviors and the flows, and that's all going into this model. And so what we did was we interfaced D3 with Angular naturally, right, to be able to get a lot of that visualization done. And we're going to take a look at it in a minute in terms of a demo. But the key thing there is that we needed to be able to start to provide different ways to handle the complexity that was coming in this model, right? And so we're going to look at it in the context of one of our enterprise applications for recruiting. The recruiting application, as you can think about it, connects hiring managers and recruiters to people who are seeking jobs, right, candidates. And if you think about a model for this application, it will encompass all three of those roles, and of course they can see some different parts of the application or not. And so you're talking about a very massive, massive model. So let's take a look, right? So here, if we take a look at the page with the model, you can see the model on the right. You can interact with the model, but the first thing we want to do is try to see if we can just filter it down. So let's go and just remove some of the roles, the admin and the hiring manager role, and kind of scope it down a little bit. So the newer model is a little bit smaller, easier to handle, and you can see on the left-hand side, and you can zoom the model, there's all the pages that you can interact with. And the pages are actually, and the size of these nodes are actually mapped to the complexity of the widget and the page. And so you can select a page. Let's go and drill into motivations. And you get all these sub-widgets there. And you can drill further to kind of see different snapshots of that page and the widget that was highlighted. So we'll click on one of those. And you get a screenshot. First, you get the deep link to the page itself and the widget that we went to and that the bot visited. And here's the widget highlighted there at the bottom. And so you see, like, initially, the abstraction is key, right? And we use some color there, and I know, like, the colors are hard to see on this monitor here. The colors are hard to see sometimes, period, and it's not very accessible, right? But we just need different ways to be able to guide the user in seeing and visualizing and flipping back between one level of abstraction and the other, right? And so there's more work to be done there. And so that's the visualization. Another key thing that you'll see with artificial intelligence and machine learning systems is that there's usually a lot of data that needs to be presented, right? So there's complexity just in the nature of whatever is going on typically, right? Here, these bots are generating thousands of tests. And what does that mean? They're generating thousands of tests. That means that there's thousands upon thousands of results for those tests, right? And how does the user really start to handle getting to the information to see what flows were covered and what kind of results there were and getting to the results that matter and so on and so forth? And so we leverage Angular Material to kind of help us create those very simple flows and give the user like a minimal amount of data at a time and be able to see the things that they care about and hide away the things that they don't care about at a given time, right? All the animations are called fancy and all pretty, but they serve a purpose, right? It's not just animations, right? And so we'll also look at a demo of this. You need a test case that's human readable. Like, it has to be English. Like, how do we know what the bots did? How can we trust what they did if we don't really have that information that we can see? So you can see that, create a new task, set the name field to X and so on and so forth, and you kind of traverse through until you verify something on the screen and so on and so forth. And on the right, on the mobile view, you start to see a view of the test results. You start to see some of the components, some of the widgets, and some of the reuse there for how engineers can drill to get to the information that they want. And so let's take a closer look. So if we go into the runs page and we start to look at it, you'll start to see different tiles for the runs that we had, right? And so there's maybe some runs for regression, and you see those tiles there. You start to see like different widgets indicating like bugs and issues that might have been found during that run, a list of the kind of techniques and the coverage that's there. And so if we click into the regression run number 1, then we can start to see a view of at least the total amount of tests that were run, and then those that pass and those that failed, right? And then you got your coverage map on the side, and then you start to see a key for the different icons. And those icons in that legend are actually used on the runs page, right? And we kind of reuse those same widgets for passing and failing. So if we drill into some passing boundary tests and ignore the GUIDs here, you'll see that just a development build, but we'll drill into like any particular test case and start to see what exactly those look like. And so you normally get some sort of high-level goal for the test, and you're navigating to some page and doing some stuff, and then there's usually a screenshot of the verification point. And so if we drill into navigating as maybe a high-level step here, we'll start to see like a lot of the details behind filling out that form, if you want to see those details. Otherwise, you can just use that top-level abstraction, right? And really quickly, let's just look at the accessibility report. So we look for WCAG issues, and one of the cool things that we need to be able to do is group issues. So if we go into closed opportunities, we'll start to see a number of issues, and there's 53 issues around the ID attribute not being unique, right? And so if we drill into that, we start to see, well, okay, if a user really cares about this, then they can drill into it, see what page this is, see what element locators they are, and kind of refresh. And we use different locators at different points, and then you probably care about some suggested resolution. And so you can scroll through the issues and see all of the accessibility issues that were found in the application around that particular high-level category of issue, right? And so it's really pretty challenging when you start to think about all the variables and putting it together, right? But frameworks help. Like, frameworks aren't the solution, and obviously good design and good design practices are the solution, but a framework that helps guide you towards those solutions, is like, in our world, priceless, right? And so that's the data presentation challenge. And the last point around this is really around training. So like I mentioned, these systems are usually pretty bad at first, right? Like they suck, right? And that's okay. You can train the system up front, and we'll talk about some of that. But in any case, that system always needs to evolve. And so you have to build in, one of the ways you can do it is to build in mechanisms for users to provide feedback, right? And this feedback is typically after the fact, is an approach called reinforcement learning, where you find out whether or not you did a good job or not after the fact, and then you feed that back into the model, and you do some fancy math to propagate, and then you can come back forward and do it better. And again, it seems like magic, but it's really just math. So let's take a look at that. In terms of user feedback, like, we train the system on user stories and how to understand user stories. And so you see tiles here with some different user stories for the application. And what you can do is drill into a user story, and you can actually see like how many of these sentences were categorized or classified and labeled. Here we have like 18 unlabeled, so we can actually go in and actually start to do our labeling, right? And this could be the analyst saying that, these are good, and here, all we're doing is using natural language processing to start to understand the structure of the sentence and make sure that we identify roles and stuff correctly. So you can start training and saying, yes, this is good, maybe no, this is not good. And if it's not good, you can actually present like what classifier it is, right? So maybe this is an update, right? And then you can keep on training and adding classifiers and so on and so forth. And the whole idea here is just that after you put the system in the wild, it needs to be able to evolve, because different things change, right? And that's one of the key aspects about artificial intelligence and machine learning systems. They're actually very good at adapting and doing those things that we can't do very well procedurally and programmatically, right? Like drive cars, right? Well, we don't know if they're good at that yet, but we seem to be trusting them. All right, so that's the user feedback. And you know, there's a whole bunch of other tools that we built, right? Because I showed you like a reinforcement learning mechanism, but there's also the idea of doing supervised learning, which is where you label things up front and you train the system. So it already has the answer. It has an example, like these are 1,000 examples of a shopping cart, right? And you've already labeled them. And that's pretty tedious to do, but you have to do it if you're building this type of system. Like data is really your first-class citizen. And so this is the tool that we built that allows us to do the labeling. At different levels, we can actually put constraints on some of the behaviors of the fields in the application and so on and so forth. And ideally, we want to be able to build this right into the application and so on and so forth, right? You know, the startups like Test.ai would pay mechanical Turkers to use tools like this to label a whole bunch of stuff and get their training data relatively cheaply. But we also wanted to research some other ways to help with the data problem and build some other tools. And I forgot to mention, but we're using Angular on those tools as well. But one of the key things that has been out there is just doing mutations on the data, right? So a popular technique in image recognition, if you have a small sample set, and there's a video of this on YouTube with a self-driving car, is that you can take 7,000 images, which is not very much training data, and you can expand it by mutating it, right? Changing colors, distorting the image, and so on and so forth, and just applying algorithms. And so we wanted to apply this to our problem. And so we had one of our interns build an application that does that, right? And so you can go into the application, and it's an extension to Chrome, and you can just start selecting elements that you want to mutate on the page, and then it just runs all these mutations in place and generates new training data by changing colors, moving things around, and so on and so forth, right? That was a real cool internship project. We hired him. Sorry, just telling you what you can do if you come to Ultimate. So there's lots of possibilities for leveraging Angular to help us with these things. But those are just UI design challenges, right? My talk is about leveraging these to do testing. And we aren't there yet, but I need your help, right? Like I need to join forces with the UI and UX design communities, and I have some ideas, things that I've been churning for a while. You know, when I was in graduate school, like my research was around building self-testable systems, like systems that can test themselves. And the more I think about these problems, the more I know that we need to build AI into a lot of the frameworks that we use. They're already doing it, like Test.ai teamed up with Jonathan Lips to put AI-based locators into Selenium, right? This is a challenge to the Angular community. Like we need stuff like self-testing Angular components because it will be very, very powerful. And so we'll talk about that. The other thing that's important is to actually start to treat testing as a feature, and we'll get into why and what that really means. And I love to hear you guys talking about design language systems because there's so much opportunity there to make AI-driven testing better. And so let's go through that pretty quickly in terms of the self-testing Angular. We saw all these wonderful presentations, and it made me really happy to see all the stuff that was going on in the previous two talks, right? Because, yeah, there's Lighthouse and there's all these cool things, but what if Angular had some of that stuff built in? Like, what if there's a dev mode that allows you to get feedback on accessibility, to get feedback on performance as you build the app, and so on and so forth? Maybe even do robustness testing to tell you, okay, well, you know, Angular tells you that you're wired up to these external services, and then, you know, through some clever algorithms, you can figure out how to turn some of those services off and do some testing and see if JavaScript errors occur and if you're actually doing a good job during development, right? Right there and right then. The other idea is about testing as a feature, right? And this is really about building tools that help you to capture user feedback in multiple ways. Like, what is the user doing, right? They're navigating through this application, doing these scenarios. They're complaining about these defects, right? Because you've built in features to capture defects straight from the user, and you're capturing all their configurations, right? Because when we do testing, guess what? We have to pretend to be real users. But real users don't have to pretend, right? And so we also did some work on this, and our prototype of testing as a feature basically allows you to give the user the ability to select an item, and this is where the issues started to occur for them, and they can put in some information. They can maybe highlight some parts of the screen and select some widgets that are of concern, that where the issue really lied, and start to provide the steps of the bug, right? They're basically filing a bug in the live app, and then they're going to submit that. And the cool part is when they submit that, guess what you have? You have all the apps that they're running, you have their browser configuration, you have all the information for exactly what they were doing. And if you were so lucky, you have the ability to trace that path that they had. I mean, I'm just dreaming here, but I'm telling you it's possible. And if you have all of that, then you have issues that matter for your development team to fix. That alone is valuable. Forget AI. That alone is just valuable. But when I look at this from a different perspective, you know what I see? I see training data, right? I see images that tell me what users' bugs look like. I see paths that should be tested by bots and that we should pay more attention to. And for me, that's like just the future of where we're going to go. Because if you think about it, there's systems that we actually can't test in the lab today. Google Maps, how do you test Google Maps in the lab? Who knows that the Starbucks moved from outside to inside? No one. Only us in the field, right? And so that's very important. And last but not least, the DLS is key, right? I mean, of course, I'm in quality. I love guidelines, best practices, and all that stuff. But what I love more is the patterns and the reusable components, because I see opportunities to put metadata on top of those elements and the components that help with testing. Just alone having like these guidelines means that you can train your bots easier, right? Because not only does it look the same across your individual product, but now all your product lines have similar things, right? So you just have to train your bot kind of once to really understand these variations, and now it can operate on that product line, right? And all the tools that we saw, I think it was called, what, Nest.js? Man, I mean, I was jumping for joy when I saw some of these tools. Not only was there testing involved, which is always good, right? But I think about all these tools just supporting these initiatives, right? Configuration and so on and so forth. All right, so that was cool. Like, I get up here to talk about all this stuff and showcase it, but like, there's a lot of people working, smart people that are smarter than me working on this problem. And I get to work with them every day and solve these challenges, right? So a lot of folks at Ultimate. Zach, we've been talking about some stuff, but 2019 is the year to do it. And Jason Arbin, CEO of Test.ai, we teach a course on AI for testing and kind of drill into that stuff. And more importantly, like this community, right? Because I'm making a call to you guys to help us do this. So I'm thanking you in advance. As part of the mission for the AI for Software Testing Association, AItesting.org, we're just trying to create awareness and try to see if we can get communities together to solve these problems. And I really believe that like some of the stuff that's going on at this conference is key to that. So thank you very much.
Talks like these are why I come to conferences. Like, let's be honest, we got 8 hours of talks we watched, 2 days. Yep. I'm not going to remember everything. Like, there's only so much I can learn. But what I come to conferences for, we've talked about this before on the podcast, is to be inspired. to think like these are people that are thinking about the next generation of the problems that we want to solve, not just the problems of today.
Yeah, and I think we're even like always thinking about what's the latest and greatest. This is even further. This is like where I'm like, this is where we need to be, and how do we actually get there? I think, Tariq, that was amazing. Like,
Thanks.
And made AI seem a lot easier for me to understand. I was always like, it's way over my head. But you put it really well. And I want to see more of that testing. That's amazing.
I mean, that's one of the goals that we kind of have with the association. And I mentioned Jason and I teach a course because, like, you know, I used to be a professor in a past life. That's why I was in North Dakota. And I believe like anyone can learn anything, but you have to approach the subject matter. Number one, you have to master it. And then you have to know how to kind of deliver it to folks that may not be experts in it, right? And so this isn't the first time I've spoken about this. And so over time, it becomes a lot easier to kind of get the audience to digest it. And people have given me that feedback from before. So.
Yeah, no, I think that's like a great takeaway from that. If we were wanting to implement more AI in our testing, where do we start?
Well, you can check the website, aitesting.org, but I always tell people there's so much free material. Andrew Ng has a free course on YouTube from Stanford University that really gives you a good foundation of that stuff. There's books. You're just seeing a lot of stuff out there that's a lot of buzz and a lot of hype. Honestly, like the first starting point, I think, is to get some of that background knowledge and then get your hands dirty, right? And so looking at Python, looking at TensorFlow, like these are all out there. You don't have to pay anyone for anything, right? And the material is there, and you can just start to learn it and get your hands dirty.
Well, thank you again.
Yeah.
I'm really inspired. I'm taking this back to Netflix and try to get a machine to write more of my code so I can just go chill in Oahu.
Yeah, you can just, exactly, there you go.
I would like to throw it back.
All right, well, thank you so much.
Cool, thank you guys.